Dear students, good morning. Today we will learn how to calculate vapor pressure at one temperature if vapor pressure at another temperature is given using Clausius Clapeyron equation. The vapor pressure of ethyl ether is 185 mmHg at 0 degrees centigrade. The latent heat of vaporization is 92.5 calories per gram. Calculate the vapor pressure at 20 degrees centigrade. Here, vapor pressure at 0 degrees is given. The question is to calculate vapor pressure at 20 degrees centigrade. Vapor pressure at one temperature is given. Asked to calculate vapor pressure at another temperature. And the data required is latent heat of vaporization data is given. Latent heat of vaporization is required here because vapor is forming here. So before discussing this problem, first let us discuss Clausius Clapeyron equation, which gives the temperature dependency of vapor pressure. So first what is suppose vapor pressure? We will discuss briefly how vapor pressure depends on temperature. Vapor pressure, we denote it using letter P. If you write PT, it becomes, according to our McGraw, Smith and all that chemical engineering notation, if you write PT, total pressure, small p, partial pressure. Here vapor pressure, like this we denote. So vapor pressure. Just consider water. Consider water at 50 degrees centigrade. So pure water it is, pure water. So depending on this level of temperature, then water molecules will evaporate and exerts their pressure. This is called vapor pressure of pure water at 50 degrees centigrade. Vapor pressure of pure water at 50 degrees centigrade. Suppose increase the temperature to 70 degrees centigrade. Okay? Then what happens? More number of molecules will evaporate. Therefore, the pressure exerted will also increase. So, and so on. So, what you can conclude here is vapor pressure is directly proportional to the temperature. Means vapor pressure depends on temperature, you can write. Vapor pressure depends on temperature. Vapor pressure depends on temperature. So, how it depends on temperature? This dependency of vapor pressure on temperature is given by Clausius Clapeyron equation. Dependency of vapor pressure on temperature. Dependency of vapor pressure on temperature is given by Clausius Clapeyron equation. Clausius Clapeyron equation. Okay. So what is that? The Clausius Clapeyron equation is ln P2 by P1 equal to minus lambda by R into 1 by T2 minus 1 by T1. This is Clausius Clapeyron equation. This is Clausius Clapeyron equation. First we will discuss this Clausius Clapeyron equation before solving this problem. Then it is simple substitution only. So ln P2 by P1. P1 is equal to Vp at temperature T1. P2 is equal to Vp at P1, P2. Two sets of conditions we have here. Then R is gas constant, lambda is latent heat of vaporization. Latent heat of vaporization. Why latent heat of vaporization is taken in this equation? Because liquid is changing its state from liquid state to vapor state. The phase is changing from liquid phase to vapor phase. That is why here lambda is included in the equation, and its units are usually, this is only one example unit. In other units also you can write another way. So one example unit, either calorie per gram or calorie per gram mole. Usually data is available for latent heat of vaporization either in calories per gram or calories per gram mole or kilocalories per kg mole, anything, kilocalories per kg mole, etc. Okay, so this is lambda. Then R is equal to gas constant. You know many other numerical values of gas constant. Here which one is required? We can see here, this is calories, that is energy. What is latent heat of vaporization here? Suppose 100 calories per gram, then 100 calories of heat energy is utilized in the transformation of liquid to vapor, like that. So gas constant value also need to be written in terms of energy units only, because other 82.06 and other numerical values also you have. Here what we need to take is 1.99 calories per gram mole per Kelvin. This is the R value we need to take. Here it's of course actually 0.2, some others uses 2 also roughly, some uses 1.987, you can take 1.99. So here calories per gram mole per Kelvin, so here lambda is also calories per gram mole, and T is in T1 and T2. Compulsory these need to be substituted only in absolute temperature, that is Kelvin. Okay. Now if you check out the units here, you know that any equation units of LHS need to be equal to the units of RHS. If you check out these units here, no units, because P2 by P1 gets cancelled. Now, so this also, if you check here, what are the units? Lambda is calorie per gram mole, and R value is calorie per gram mole per Kelvin, and then into 1 by Kelvin. Temperature is 1 by Kelvin. Okay, so this everything will get cancelled. No units. Here also no units. Units are tallying. So first what you need to remember is when you are using R value, this one, when you are using this R value, lambda need to be substituted only in calorie per gram mole. Okay, lambda is need to be substituted only in calorie per gram mole. But sometimes in the problem they will give you lambda value in calorie per gram mole only, but sometimes they give in calories per gram. If it is given in calorie per gram mole, you can use directly, but if not, per gram is given means you need to convert per gram to the gram mole. Okay, So this is a Clausius Clapeyron equation. Using this equation, if you know one set of conditions, if you know P1 at T1, P2 at T2 can be calculated. Then R value we know, lambda will be supplied as data. So the application of Clausius Clapeyron equation is what now? What we have studied? The application of Clausius Clapeyron equation. If you know vapor pressure at one temperature, you can calculate vapor pressure at another temperature. That way you can use Clausius Clapeyron equation. Okay. So now we will come to the problem. Vapor pressure of ethyl ether. Vapor pressure of ethyl ether at 0 degrees centigrade equal to 185 mm Hg. Here 0 degrees, but we never substitute in centigrade. Anyway, we need to convert this 0 degrees centigrade to Kelvin. So 273 it is. So and then the question is Vp of ethyl ether at 20 degrees is how much? Latent heat of vaporization lambda is given as 92.5 calorie per gram. So you need to check first, is it given per gram or per gram mole? Because it is given per gram. Then what is the molecular weight? Molecular weight of ethyl ether. Molecular weight of ethyl ether is equal to 74. Okay. Molecular weight of ethyl ether is 74. So 92.5 by, here weight is in the denominator. So weight by molecular weight here. Weight by molecular weight. Number of moles. Weight by molecular weight is equal to number of moles. Okay. So weight by, here in the denominator, by molecular weight. This becomes 92.5 into 74. So much of gram moles. Okay. So we got lambda value. We got lambda value in calories per gram mole. Calories per gram mole. Next. So shall we write the Clausius Clapeyron equation? Clausius Clapeyron equation is given by ln P2 by P1 is equal to minus lambda by R into 1 by T2 minus 1 by T1. Here you please observe here P2 we started with P2 by P1. Here also we have started with the T2 and T1. Then minus sign is there here. And some write like this. They don't write minus sign here, but here they write T1. Here T2. Both the ways it is correct only, no problem. Okay. So we can use this equation like this. Therefore, what is T1? P2, P1. Is it P1 now? T1 equal to 0 degrees centigrade, that is 273 Kelvin, and P1 equal to 185 mm Hg. Okay, this is one set. Next, T2 is equal to 20 degrees centigrade, that is 20 plus 273, that is 293 Kelvin. 293 Kelvin. Then P2 is equal to how much? That is the question. Therefore, ln P2 you don't know how much it is. P2 you keep P2 only. So P2 by 185 minus that lambda is how much? Lambda 92.5 into 74 calories per gram mole by R 1.99 into 1 by T2. T2 is 293 minus 1 by 273. Okay, like that you can write. So solving P2 is equal to 436.6 because 185 is in MMHG, P2 also in MMHG only. Okay, so this shall I write? Lambda by R into 1 by T2 293 minus 1 by 273. Okay, so vapor pressure of ethyl ether at 20 degrees centigrade is equal to 436 mmHg. This is the answer. Okay. In the similarly, you can calculate Vp at any other temperature. If we know the data, what data is required? Some P1 and lambda. Okay, so this is the application of Clausius Clapeyron equation. If we know vapor pressure at one temperature, we can calculate vapor pressure at any other temperature using Clausius Clapeyron equation, and latent heat of vaporization data is required. That R you need to take in calories per gram mole per Kelvin. So lambda also need to be taken in calories per gram mole. If not given per gram mole, you need to convert. Another important point is T should be substituted only in Kelvin. Thank you.